Thank you very much, everybody. Thank you, thank you. Good morning, good morning. I'm very excited to be here with you. So today, in if we should be like in 1 second or couple of seconds, is that what we're trying to do at Genobank is having obviously every single human being be able to establish ownership and control over their genomic data, and then be able to connect it with generative AI platforms with absolute privacy. So that's in essence what we are doing. Oh, thank you. Sorry. And during the presentation, I'll tell you a little bit about me and how we've been building the platform. It's not a new platform. We've been working 4 years now, and since 2018, 2019. And basically, the way we're doing while the slides are showing in the screen is we started first to decentralize the governance of genomic data by using blockchain technology. So basically, the first stage in the journey was that I was already in fintech 2015, already working in blockchain technology using wallets, basically to decentralize finance. But in 2017, while I was already living here in the United States, in Palo Alto, my son was diagnosed with a rare disease. So we had an accident. He had 24 months old. And he was diagnosed with Glanzmann thrombosthenia by the Stanford Lucille Children's Hospital. So he was administered Novo 7 and it didn't work. And now we know why. And this is part of the presentation. So the main problem we want to solve is this one. Unfortunately, I admire 23andMe and the founder Anne, but it's a centralized model. So it served for many years, not anymore. So this model is not scalable anymore because it presents a lot of cybersecurity problems. So we think our vision is that next step is to decentralize the governance, because now computing is cheap enough for everybody to have its own node, right? Its own virtual machine. And so having genetic tests, having genetic data is becoming a huge liability. So this is just from today. I just found it on my Facebook. This is actually a law firm, like saying, hey, if you feel you were affected, you can be up to $750. My times 6.9 million people affected. I mean, it's going to be problematic for 23andMe, to say the least. On top of hacks, now we also have generative AI platforms generating synthetic human DNA data, which is big data, not for nefarious purposes, obviously, it's for research. But the main problem is now, how can you distinguish original data or let's say authentic human DNA data coming from a biosample from the fake data, and that is also consented and it also has the correct digital rights. So part of our investigation is really important here. If you can please scan this QR code, I promise it's not not a cybersecurity threat. You will see what we call a phygital or a digital twin of a biosample, right, in the blockchain. So you'll be able to verify the provenance of a biosample using blockchain technology. So this is, in essence, the foundation of our project. We want everybody to be able to have a pseudo-anonymous identity, and then be able to track where are your biosample and where is your biodata. And this we already do that. So we didn't want to drink our own Kool-Aid, so we published a paper, or we wanted to be published by the British Blockchain Association. They don't even publish us. They awarded us in 2020, but because we published a paper called Privacy Loss, Genomic Data, and Non-Fungible Tokens. So basically, we're using blockchain technology to program privacy per biosample or per biodata. It's a legal tech, basically, approach. We also have 3 patents, and this is kind of the story. So we started here. We enabled the first kit for Latino ancestry, so where you could mint your ancestry image as an NFT and then interchange it just for fun, right? But behind the scenes, you also were tokenizing or notarizing your SNPs, right? Your personal variants. The second use case, so the pandemic hit, and we helped more than 333,000 people to get on board uh, uh, airlines and trains. This was because airlines didn't trust laboratories. They didn't have to, and we made that possible through cryptographic signatures, right? So laboratories will cryptographically sign their HL7 test, like usually COVID-19, and then the computers of the airline could consume these certificates and verify them using blockchain technology in order to discharge the legal implications to the laboratory. This had no precedence in the world. So this is the problems that really blockchain can solve. Again, these two entities that they do not trust each other, now they can, because the test, the COVID-19 attestation, is verifiable. Same way, last year we did the world's first paternity test that is also verifiable by blockchain. So if you are also curious, you can see that this QR code is really packed with information. It has all the attestations required by law, where any legal authority can check. Because, as you may know, the paternity test is one of the most faked tests in the world. So this is currently our work. So right now we are transitioning to NGS datasets. So now we allow parents specifically to tokenize newborn's biosample. Then we open an NFT gated virtual machine that they control, they own, and then they are able to govern all the data using, again, tokens. So basically it's like using cookies, but in the opposite side. In the world, when you navigate a web, the enterprise or the company will give you cookies to track you. In this case, the family will give cookies to the researcher to track them. Right? So we are working in the opposite, and this is very important for privacy and data control. Right? So here's where we are at. So hopefully this video can be played. So this is actually how the platform works. I don't know if this is going to work. Let me see. Well, it's sometimes challenge to work. What I wanted to show in this video is an interaction with Geniverse. That's part of the platform where I can literally logging into my own virtual machine and then interact with ChatGPT. So in the demo, I was going to ask ChatGPT, hey, please help me to know if I have risk to develop cardiovascular diseases. So obviously ChatGPT will not analyze my data, but ChatGPT is really good by bringing the SNPs that are related from Snipedia, and then I can create a query to my own data bank and then make a personalized report. So it abstracts some of the bioinformatics kind of knowledge, right? So by using this Geniverse, I was able to analyze myself. I am not a genetist. My background is in cybersecurity and telecommunications. I was able to notice that the gene or the diagnosis for Glanzmann thrombocythemia was absent. So my son was misdiagnosed. Actually, he has some, well, we think we have, and actually it's been reviewed by the clinician, Hermansky-Pudlak syndrome. This is why I think Novo7 that is indicated for Glanzmann thrombocythemia didn't work on him. So we are solving that case. But this is the kind of conversations we want to empower parents, right? We don't want to obviously be the new clinicians. We want to have more educated discussions with our doctors, right? Like saying, hey, I analyzed the variants, right? The genes, the ITGA2B, it seems they're right. I mean, it's not a notation there, but We annotated this with CleanBar because the robot annotates with CleanBar, and this is what is happening. So now the problem is that this new syndrome apparently has a variant that will affect his lungs. So I now need to monitor his lungs. So now it's not only genetic information that we're bringing in, but it's also radiology. And we also want people to own and control their radiology images. And the way to do it is, again, to tokenize it and then integrate it. So with this evolving, now we have TimeGPT, which can analyze time series data sets. So we are also integrating that. And this is the new version. So we're raising money to build the predictive GenoVolt 2.0. So currently we have Thread3 clinical laboratories connected, basically doing attestations in our platform. We have 4 white label DNA kits, or our startup is a protocol, so every single laboratory can use it, even 23andMe, hopefully. We are surpassing $350,000 in revenue. We have raised 1.5, and there is still $500,000 in our seed round if somebody would be interested. So basically, this is the end of the well, I have 2 more slides. Hopefully, have some additional minutes. Let's see. Oh, I don't have the time, but anyhow, so basically what we dream of building is the personal Jarvis for everybody in genomics. So it's a platform that you can ask what's going on with your genetic data in terms of the 5 big. So it's pharmacogenomics, nutrigenomics, personalized medicine, and so on and so on, ancestry, and so on and so forth, right? And we are also asking for an FDA Section 360, which is a clinical decision software, decision support software. We will never, at least today, like aspire to be a clinical per se software, but it's a clinical decision support software, and this is well defined with the FDA. So we think this is the future. The future is a Spotify for genomics. Let's say everybody is a node, right? Like an artist. And what we are trying to build is a platform where you can share your data, obviously be compensated, but the artificial intelligence will help us to find the data, right? So it's again, like you are looking for Latin or pop music, Spotify will search for you and will find the song. So in the same way, but for decentralized clinical trials, we think this is the future, and laboratories, patients, and physicians can work together to make this possible. So this is the end of the presentation. Thank you very much. Junot Quiroz is our latest researcher. He has osteogenesis imperfecta. He also learned about his diagnosis using Genoverse IO for the first time. He didn't know for 30 years what specific variant he had. So thank you very much.
Unfortunately,
We have time for one question. Anyone?
Hey, since GPT and equivalents are inherently centralized,
Yep.
how do you avoid the logical problem of that getting rid of the security benefits from decentralized blockchain-based storage?
No, very good question. So what is decentralized is your genomic data. Let's put it in the web. So my personal data will always be privatized, right? The only thing that we interact with ChatGPT is with the questions. Again, is like, how can I know the biomarkers or the SNPs that are related, let's say, for Alzheimer's, right? So ChatGPT, the first thing that ChatGPT will tell you is like, I am not a medic, I am not a clinician, but these are the biomarkers. So we filter the conversation, we transform those into a JSON, and then we query your data using confidential compute. So information is never leaked back to the AI, only the question, right? And we also take care of the privacy because all our users use the same API. So it's like one user is like asking all the questions, so you cannot relate to who made the question. But the future relies is if we get enough traction we will obviously want to build an open and decentralized model with DNA. No, we cannot do that today because it's super expensive. The conversations we had with OpenAI is that they will charge us a minimum of $2 million to start training our model. And they need at least like 100,000 data sets for training. So we are in 6,600. So we are kind of advancing. We want to do that, but it's not our main objective today. Yeah. Thank you very much, Austin.